Hello, and welcome to the Learn JavaScript series. In this video, we are going to discuss data fetching from APIs using fetch. Let's get started. When discussing data fetching in JavaScript, it will be useful to get familiar with two different types of HTTP requests first. These are GET requests and POST requests. GET requests are used for retrieving data only. They can contain parameters, typically as part of the URL, which can then be decoded and accessed by the backend server API. Examples of GET requests are retrieving data such as a timeline feed for a social media website or a list of articles for a news website. POST requests are typically used for updating data. POST requests contain a body which is used to store all of the information you want to update. The body can be decoded and accessed by the backend server API, and that data can be saved in a database or used to update a part of the application. Examples of POST requests are anytime a user submits a form, like logging into a website or signing up for an account. In JavaScript, there are many libraries to fetch data from an API, but in recent years, the Fetch API has become part of the standard library. The Fetch API is an interface to fetch resources asynchronously from a server or an API. For this example, I'll be using a fake API URL that returns fake information. This allows us to test out the fetch interface without needing a backend service or an API setup. A basic fetch request is incredibly easy to set up. To perform a GET request, the only piece of information that we'll need is a URL. In this example, I am fetching a list of users from a URL, converting the response from JSON into JavaScript using the JSON method, and then console logging the list. The chained then statements are called promises, which are basically code that waits until the previous code is done before executing. Since the API can take a long time to respond relative to the speed that a program runs, it is important to wait until the API request has completed before trying to access the data. Trying to access data before it is available will lead to undefined behavior. Now, let's rewrite this example using async and await instead of promises. With async and await, we need to write a function first so that we can put the awaited code inside of it. JavaScript does not allow asynchronous code at the top level of a program. It must be contained within a function or other block of code. Using async and await, we can specify that we must wait for the fetch request to complete and also wait for the response to be converted from JSON to JavaScript before we can access the data. This makes the code more sequentially readable and ensures that any information we are waiting for will be available. If I were to remove one of the await keywords, the data variable would be a pending promise. This indicates that we have asynchronous action that is not yet completed. By using the await keyword, we can guarantee that the asynchronous action has completed and the data that we need is available. In this next example, I'm going to show how to update data via a fetch POST request. Since we are going to also use async and await in this example, I'm going to make another function, this time called createUser. I'm going to pass a first name and a last name to this function so that I can call the API endpoint to create a new user. Using the fetch API, I can first pass it the URL of the endpoint, and then for the second parameter, I can specify the options of the request. In this case, since I'm doing a POST request, I'll need to specify the method as POST. And since I want to send the first name and the last name in the POST request body, I'll need to specify the body as a JSON string containing an object with the properties first name and last name. This will guarantee my POST request will submit first name and last name values when creating a new user. After awaiting the POST request and converting the response from JSON to a JavaScript object, I can see that the POST request returned a new user ID. This indicates that the POST request was successful and a new user was created, because that is the response that was set up via the fake API endpoint. It is important when dealing with external resources to think about situations where something can go wrong. What if the API server you are trying to access is down or unresponsive? What happens if the request times out and does not return any data? To handle these scenarios, we'll need to include error handling and defensive programming as part of the data fetching process. This means that we'll need to plan for and assume that something can go wrong and handle the error accordingly. If we are trying to fetch a list of users and the server is down, we'll need to catch that error and display an error message to the user, letting them know that something went wrong. Similarly, if someone is trying to log into a website that you've created and the login API is not working, it is important to let the user know with some sort of error message so that they do not get frustrated by not being able to log in. Handling errors and informing the user what went wrong is an important part of programming, and one that I will discuss in a separate video on error handling and defensive programming. That wraps up this introduction to JavaScript data fetching using the Fetch API. As always, the description of the video will contain a link to the code sandbox that contains the code that I've written. Feel free to take a look and play around with that. Thanks for watching, please like and subscribe, and I hope you have a great day.